Hey everyone, we are starting Unit 11, which covers circles, and this is Notes 11.1, Circle Vocabulary. So really basically today, all it is learning a couple new vocabulary words that involve circles. A few of them you already know. For example, number 1A, you already know. What is AB, line segment AB, goes through the center of the circle and touches each edge. CD goes to the center, touches each edge, and EF called. Well, these are called diameters of the circle because they go through the center and they touch each edge of the circle. They are also segments. They are not lines or rays. They are segments that go through the center of each circle. Okay, B is a new word. If you notice, AB, this is line AB, they have arrows on each end. Line CD have arrows on each end. And line EF, all are touching the circle. They do not go through the circle, they are going on the outside of the circle, but they're only touching the circle at one point. These lines are called tangents. Tangent lines run directly next to a circle and only touch the circle at one point. Tangents. Okay. Letter C involve angles. So we have angle COD. Notice the vertex O is on the edge of the circle. And then we have angle ODE. ODE. The vertex D is on the edge of the circle. And then we have angle FBA. The vertex is on the edge of the circle. It doesn't matter that A to B is the diameter. It makes this angle that is on the edge of the circle. Okay? These are all called inscribed angles because they are on the inside of the inside of the circle, and the vertex is on the edge of the circle. So these are inscribed angles. Okay. Letter D. Okay, these are not diameters. AB, CD, EF, GH. Actually, GH is a diameter, but these are not all of these are diameters. And IJ. All of these have endpoints on the edge of the circle, but they do not all go through the center like diameters. So these are all called chords. Chords go through the circle, but not necessarily through the center, and have endpoints on the edges of the circle. Those are called chords. Okay, E, AB, which is a line that goes through the circle, endpoints on the circle, or points on the edge of the circle. CD is a line, points go on the 2 points on the edge of the circle. EF is another line, 2 points on the edge of the circle, and FE, actually FX right here, F and this point here are on the edge of the circle. So these are all lines that just go straight through the circle. It doesn't matter where they touch at two different places on the edge of the circle. These are called secants. S-E-C-A-N-T-S, secants. And the last vocabulary term you guys already know. These are angles, AOB, angle AOB, it's a really big angle, and BOD, and CUT. All these are angles that vertex is in the center. Unlike the inscribed angles where the vertex was on the edge of the circle, these angles have a vertex from the center, which makes them very simple to remember. They are just central angles, and we've talked about central angles before. Central angles have a vertex at the center. Okay, example 2 and 3 are just two circles. One of them is inside the other one. The other one only touches this circle at this point here. This one's outside of this one. This one is inside of this one. There's a specific name for this that you will learn in class. The first thing we're going to do, though, is list the radii, or the radius, of each one of these circles. So let's start with this small guy right here. So we want to find the center of this small circle. And we want to figure out how many units from the center to the edge is there. So 1, 2 units. You can count up, you can count left or right, you can count down. Each direction will be 2 units long. Okay, let's look at the big circle. So here's the big circle. You kind of have to ignore the little circle here, and you have to imagine or envision where is the center. Well, the center of this circle looks like it's going to be right there. And we can check and make sure by counting, is it the same direction to the right as it is up and down? So we're going to count 1, 2, 3, 4, 5 units to the right. And let's see if it's the same amount up. 1, 2, 3, 4, 5 units up. So that means the radius of this circle is 5. So the radius of the small is 2, the radius of the large is 5. The point of tangency. Well, let's look up here and see again, what is a tangent? Tangents are lines that touch in one place on the circle. So that point of tangency is where these two circles are touching at one place. And they're touching at one place right there where they share a point. Okay, and that point is -6, 0. Okay? And then the last one says equation of a tangent line. Remember, a tangent is an actual line that touches the edge of the circle in one place. So a tangent line that would touch both of these circles only in one place, that goes through this point, would have to be a vertical line. Okay, that is an awful, let me draw a different line. This one. A vertical line going straight up and down. Okay, and it touches right here at the point of tangency. Well, vertical lines, if you guys remember, hoi, vux. Horizontal lines have 0 slopes and y equals a number equation. Vertical lines have undefined slopes with x equals a number equation. Well, since this is a vertical line, our equation is going to look like this. X equals, and what number does it go through on the x-axis? It goes through -6. So our vertical line equation is x equals -6. Okay, same thing with example 3. We find the radius of the small circle. So here's the center of the small circle. We count and see the distance that the radii cover, or the radius covers. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So the radius of the small circle is 3. The radius of the large circle, okay, we got to find the center. It looks like it's going to be right here. We got to make sure though. Let's count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so there's our center with a radius of 6. And the point of tangency, again, is where the two circles share a point where they touch. And it looks like it is right there. So that point is at 3, right 3, and up 3. So the point of tangency is at 3, 3. And unlike example 2 where we had a vertical line, because this line only touched both of these circles in one place, if we did a vertical line again, like this, if we drew another vertical line that went through the tangent, it would touch in more than one place on this circle. You can't have that. So in order to draw a tangent line here, we would have to draw an actual horizontal line, because it'll only touch at that one point and not anywhere else on our circle, on either one of them. So since we had to draw a horizontal line as our line, as our tangent line, then our equation of a horizontal line, back to hoi, horizontal, 0 slope, y equals a number will be our equation. So y is equal to, and where does it touch on the y-axis? At 3. So y equals 3 is our equation. Okay, we're going to cover the rest of circle vocabulary in class tomorrow. See you then.